Well, Dr. Limor, just to kick things off, there's so much I want to cover with you, and I'm hoping this is one of many episodes that you and I will have together. But I wanted to start off by first asking you, can you share a little bit about your background and what inspired you to pursue a PhD in molecular biology? And I remember hearing somewhere that before that, your background was in interior design and advertising. Is that true?
Yes, it's true.
I love that.
So, I'm in my 50s now. So I had a long career and many different reincarnations and many different, tours around the block. I have to say, when I was in high school, I was always the nerdy science kids. I loved science. I loved biology and chemistry and physics and geology and all of that. But one thing led to the other, and life took me in a totally different path, and I never thought about pursuing science initially. In fact, I never went to college. So what happened was I somehow got into advertising through copywriting. I really liked writing, and I wrote scripts for advertising, and I was pretty successful at that when I was, around 20. So I never got a chance to go to college. I started my professional life, and one thing led to the other. Then I started a small business in the interior design field, where I imported and sold beautiful sculptural lighting and furniture.
Wow.
And handmade rugs. So I was working in that industry for about 15 years until after I had my kids. But as I was approaching 40, I started feelings of inadequacy and what you might call a midlife crisis. And I just felt like it was not enough, that I'm not living my life to the fullest, that I'm not utilizing my own potential. Mm-hmm. And I was just not happy being in an industry where all I did was, sell objects of beauty that cost a lot of money. I wanted to do something more, to give more, to use my inherent talents. And through a process of exploration, I discovered science again. I was reading books about biology and genetics all the time because that just interests me. And
it's your passion.
Geez, what if I tried to dive deeper? And I had this fantasy of getting a PhD in biology, but I never went to college, so I needed to get a college degree first. So I started taking online classes and in-person classes in New York City, and I somehow managed to get a bachelor degree in 2 years.
Wow.
Because I doubled down on everything.
Smart.
And I started grad school right away. I before I even finished my undergrad, I applied to grad school, and I started a program in molecular biology. And I found a very specific passion in cancer research, and I started working at a cancer lab. And that cancer lab was focused on cellular metabolism, so all the ways in which there's signals in our cells that signal to the cell whether it should divide or not. Mm-hmm. And very often, cancer hijack those signals because cancer tries to multiply.
Right.
So that was the beginning. Yeah, that's
wow. That's incredible. Dr. Limor, those are my favorite types of stories because, first of all, you truly are an entrepreneur. And if you know a little bit about my background, I went to a college called Babson right outside Boston. They're known for entrepreneurship, kind of hence what I'm doing now. But my background was in finance and economics. And as I shared with you prior to recording, I started well and strong because of my mom. And as an undergrad, I wrote a thesis on integrative medicine, specifically within the context of cancer. And that kind of was, you could say, the foundation of all the research that I did going forward with Well and Strong. So I love your story. And I have a heart for stories like yours where you start in a completely different area, right? And then you just stumble across something.
Linear, yeah.
Yeah, it's incredible. But you mentioned olive oil. And obviously, this is a huge area of research too, I want to say within the past decade or so. But first of all, how did you even come across olive oil in your research? And I'd love if you could obviously talk about this phenolic compound called oleocanthal, right? Mm-hmm. That most of your research has been based around with regards to its toxicity to cancer cells.
Yeah. So actually, so I first encountered oleocanthal, that phenolic compound from olive oil, before I even started research with olive oil. It was presented to me in a tiny little test tube. We call it an Eppendorf tube. I had like the purified compound that came from purifying olive oil in Greece. And our lab have done some previous work on that compound and showed that it has the ability to kill cancer cells really fast, but we're not sure how. So my job while I was doing my PhD was try to decipher the mechanism by which oleocanthal is toxic to cancer cells and less so to, or pretty much not at all, to regular cells. And I have to admit that initially, like for the first few months or almost a year that I was doing the research, I didn't even think about olive oil. All I was thinking about was about this like compound. I was pipetting it on my cells. We did some mice work. We had some mice that were prone to cancer. We gave them that compound. I completely didn't put initially two and two together. Well, not fully. All the time I had in the back of my mind, well, I wonder, is that why olive oil is good for you? Um, I always use a lot of olive oil in my cooking. I'm an avid cook. And people might say I'm a chef, but I just love to cook. I cook Mediterranean food.
Yes.
I use olive oil like water in
I'm
everything.
sure.
And, in the back of my mind, I like the fact that this compound came from olive oil, but I never even stopped for a second to appreciate that not all olive oils are the same. I just thought, okay, well, it exists in olive oil. Every olive oil has it. That's why olive oil is healthy. But then, midway through my work, everything changed when two brothers from Greece, from the island of Corfu, contacted me and told me that there are olive oil producers and their olive oil has the most oleocanthal of any other olive oil that was in existence back then. So that made me stop and think, oh, I didn't know there's differences in the amount of that compound in olive oils. But they offered to send me a bottle, and I accepted. So they sent us a bottle to the lab. I remember my PhD advisor, Dr. David Foster, and we did a shot of it. And right away was like, ooh, that's very different. I thought I knew the olive oil, but this was on a whole other level.
How would you describe that too, Dr. Limor? Like, is it like a peppery taste? Because I've sensed that too, and especially Kyoord.
We talked to my system the first time. I think by now I'm a little more used to it. So symptoms are not as extreme, but the first time I did a shot of it, I probably coughed for a good minute. It was so robust. It was a shock to the system. What happened was they sent me that oil. We did a shot, but then I was thinking like, geez, and the bottle was so fancy. They want me to use it in research. How would I use that in research? Like, I can't like pipette olive oil directly to cancer cells, or I didn't even know if we can give it to the mice. And how would I use it? So then I started thinking about it. And I really wanted to try to develop an assay that would incorporate the olive oil, and I can test the olive oil on the various cancer cells I was working on. And actually, because of my knowledge of cooking, I was able to do that. And basically, when you grow cancer cells in a lab, you grow them in a small incubator in Petri dishes, and the Petri dishes, you fill them with a buffer that gives the cells some salts and minerals and amino acids or whatever you want to provide the cells or not provide the cells. And that's an aqueous buffer. It's water-based. And we all know that water and oil don't necessarily mix unless you make a vinaigrette. So I really use mechanical force to and spin the olive oil together with the liquid, and it has some salt that help to dissolve. And we created this olive oil-rich medium that we could grow the cancer cells in.
Wow.
So we tried that. I tried it. I remember one afternoon, and I was like, okay, let's see what happens. And I came back the next morning, and all the cells were dead. And I'm like, okay, did something wrong, like I suffocated them or I contaminated it or I did something. We think about cancer is very hard to get rid of, but in a lab setting, it's actually very easy to kill your cells. You have to be very careful when you're handling them. It's not the same as having a tumor in the body.
Right.
However, not every compound kills cancer cells. So I wasn't sure. I mean, I was hoping it had something to do with that particular olive oil, but I wasn't sure. So I went down to the grocery store downstairs on First Avenue, and I bought a bottle of olive oil off the shelf. And I did the same thing, and I created the same type of medium, and I treated a plate of cancer cells, and I went home, and I came back in the morning, and all the cells were alive.
Wow.
I didn't kill them using the supermarket olive oil. So then the third day, I started really doing proper scientific method, working with the control. So I had my good olive oil from Corfu and the supermarket olive oil, and I treated 2 plates of cells, and I also treated some non-cancer cells. So I had all my controls. And then the next day when I came, it was very clear. The olive oil that had a lot of oleocanthal wiped up all the cancer cells. It was not toxic to the non-cancer cells. And the supermarket olive oil pretty much did nothing.
That's fascinating. I'm so curious too. The men that approached you from that farm, what was it, Corfu in Greece? Did they have like an inkling as to, the fact that like this oleocanthal like would kill cancer cells? Because I mean, they obviously said they wanted to include it in your research. So like, where were they coming from with that?
There was at that point, there's already published data that oleocanthal kills cancer cells that came from other labs.
Okay.
But there were no experiments done directly with olive oil.
Gotcha. That is fascinating.
Different.
Wow.
Yeah.
Now I'd love to get more into the actual like scientific mechanisms, right, by which oleocanthal can kill cancer cells. And I've heard you mention that cancer cells are very dependent on lysosomes. And I'd love if you could also just break that down for listeners, because I think that's one of the primary forces, right, by which oleocanthal is so effective.
Exactly. So I think you hit the nail on the head. It's one of the primary ways by which it affects cancer cells. It's definitely not the only one. Oleocanthal is a pretty small molecule. It penetrates the cell wall easily. Most drug compounds that are developed, they're larger molecules, so they need a way to be transported into the cells. But a lot of natural molecules like oleocanthal are small enough and they can do that. And it's a very, the chemical structure of it is very, I would say, active or sticky. It can adhere to different proteins. So there's definitely more than one mechanism, and other research groups have highlighted other mechanisms. But what we found is the effect that it has on lysosomes, and that's pretty fascinating. And that also probably explains why it's more toxic to cancer cells rather than regular cells. So every cell in our body have many different structures inside of it that we call organelles. Probably everybody knows about the nucleus, right? That's kind of like the center, the heart of the cell. And there's many other things like mitochondria or ribosomes. There's a lot of different structures, and each one has a specific function. And cells have a lot of lysosomes. So lysosomes, if you remember something from high school biology or
having flashbacks,
often are referred to as the recycling centers of the cells. Maybe you heard about that. And so I'll tell you a little bit more about what lysosomes do. So lysosomes are small bodies that are membrane bound inside a cell, and they're basically sacs in which chemical reactions can happen, and they're mostly chemical reactions that have to do with degradation, hence cycling. So proteins that are not needed anymore, fatty acids that are not needed anymore, and even nucleic acids like RNAs or DNA can be degraded inside of lysosomes. It's a very acidic environment. In order to, most of the enzymes that are active in the lysosomes are working better in acidic environment, and that's why they're contained in a membrane. The acidity would not affect the rest of the cell because the rest of the cell is not acidic. So what we saw is that the oleocanthal not only penetrates the cell easily, it penetrates the lysosomes, but in the lysosome it pokes holes. So it makes the lysosomes very permeable and leaky. Two things happen. One is they can't function as well as a normal unharmed lysosome can function. And the other thing that happens is they leak acidic medium. So the cell becomes more acidic and is very toxic.
Right.
And therefore, the cells can expire, can die right away, and a process called either necrosis or apoptosis. Now, what happens is cancer cells have several cancer, not every cancer cell, but by far and by large, cancer cells have more lysosomes, and because they're more reliant on lysosomes for survival. And for that is when tumors start, they're usually not serviced or not vascularized, not serviced by any blood vessels, and they don't have ways of getting nutrients in. So what they do is they recycle every nutrients they get from the outside environment in order to create the micronutrients they need for growth. So cancer cells tend to have many more lysosomes. The other thing that we found out that's really interesting is that cancer cells that become therapy resistant, that become chemotherapy resistant, one of the mechanisms by which they become resistant is by using their lysosomes, because the lysosomes can merge with the cell wall and they can exclude some toxins. So if the cancer cells receive any chemotherapy agent, they treat it as a foreign thing, as a toxin. They can exocytosis, it's called, to like set it out of the cell. And it doesn't happen. So if you affect cancer cells' lysosomes, there's a theory that they would be more sensitive to traditional chemotherapy. So the combination of harming lysosomes and delivering chemotherapy is very strong.
Do you know what's so interesting, Dr. Limor? Obviously, I mentioned you have done a lot of research on, integrative therapies, meaning for listeners, like it's a complementary approach, right? Or an integrative approach, rather, like couples conventional therapies with complementary therapies. And one thing, too, that I found to be really interesting is the benefits of fasting for patients who are undergoing chemotherapy. And I'm sure you've read a lot about this, but it's basically protective of your healthy cells while making cancer cells more, I guess you could say, like, exposed, or they become very stressed, which makes chemotherapy more effective. So with that said, I mean, would like fasting, like the mechanisms by which fasting works, also kind of like be similar to what you're describing here with the oleocanthal and the lysosomes?
Absolutely. And the reason for that has nothing to do with oleocanthal olive oil. It has to do with an enzyme that also we all have in our cells. It's a big enzymatic complex called mTOR. And as you probably know, fasting mimics mTOR inhibition, and mTOR lives on the lysosomes. So mTOR is a big, very complex enzyme complex that under normal conditions, every cell in our body is kind of a command center that gets upstream signals about nutrient sufficiency. Do we have enough amino acids? Do we have enough glucose? Do we have enough fatty acids? It translates that into a signal of hold or grow. And mTOR lives on lysosomes. So when the lysosome becomes unfunctional, mTOR is inhibited.
Very interesting.
Not seeing its function properly. Now, often cancer cells hijack the mTOR pathways, and they have genetic mutations that take off those checks and balances. So, and that's why, and actually our lab specializes in that, so that's why I know. But in a way, this is the reason why we started working with oleocanthal, because there's some indication that it might be inhibitory on mTOR.
So interesting.
mTOR is because it damages the lysosomes. So I'm a big believer in fasting for as an adjuvant therapy for cancer therapy. It can make traditional chemotherapy more effective.
Yeah, I had my mom do a 36-hour fast prior to her first session on Monday, and then a 24-hour fast afterwards. And again, I was doing so much reading this past week. And it's so funny too, Dr. Limor, because like some of the nurses that were at the center like never even heard about coupling fasting with chemo. They're like, really? That's so interesting. So I, like you, become very passionate and excited when I, hear about all these new discoveries, and that's why you want to share it with people too, right? If you could do anything to help.
You have to advocate for yourself. I have to say, I am a big believer in a scientific method.
Yeah.
Everything that I'm saying, everything that we're discussing, is based on some evidence we have. Is it conclusive? Is it 100%? Absolutely not. Never. That's the beauty of the scientific method.
Right.
You need more and more data, more information. And sometimes you're proven wrong. Sometimes, like years of experiment, you realize you had a confounding factor you didn't think about.
Right.
That messed up your relationship between, cause and effect.
Right.
And but there's really only one way of getting to these results. And I think the reason why, when you go to a hospital, it's not, for example, that's something that's not recommended. It's probably just like not enough evidence there about its effect. It's not enough clinical trial.
Yeah.
By the way, which commercial body would have an benefit to do clinical trials on fasting?
I know.
Fasting.
Yep. Oh, that's a whole other conversation, Dr. Limor. Whole other conversation. Yeah. No, I know.
Can we do? But this is our system.
Yeah.
If somebody could charge, like $1,000 a day for fasting.
Oh, I know. I know. It is. Yeah, I agree 100%. It is encouraging, not to diverge, but it's encouraging to see that some complementary therapies are now actually being, performed in clinical trials, like the mistletoe trial at Johns Hopkins. I think it recently passed phase 2, but Evilise is a good friend of mine, and it's been so wonderful to watch her passion for mistletoe, now actually be, brought to clinical trials and brought more awareness. So that's encouraging. But going back to olive oil, so all of this work that you did was done in a lab setting, right? Now let's take it and put it for, an actual patient who either like is experiencing cancer or even someone who just, again, wants like a more integrative approach. What does that look like in terms of serving size of the olive oil and perhaps like stacking therapies, right? Like we hear about the benefits of stacking therapies. Like, are there certain things you might want to stack with olive oil consumption, like fasting, or I don't know, just curious what your thoughts are for all that.
Thinking about the mechanism of that, that can be something that can be done, as you mentioned, in combination or by itself. It doesn't have any indications against it, as far as I know.
Yeah.
But in our hands, the other thing I've done in the lab setting is compare different olive oils with different oleocanthal concentrations in their ability to kill the cancer cells. And it's a very linear graph. The more oleocanthal the oil has, the more toxic it is. And what I did was, for example, if we have one oil that has half-phenolic over different oil, if I use double of that in a lab setting, I could get the same result. So on that level, we saw a pretty linear correlation. So the answer to that is that if you want to use olive oil for wellness, for assisting with any other therapy, it's not a medicine, it's food, right? You can consume as much as you want, unless some kind of calorie restriction or limit to the calories you wanna consume. Olive oil is fat; it has 120 calories per serving. So it's not. It's something you should keep in the back of your mind if you go like, okay, well, I want to have a cup of olive oil. But the thing is, if you're using an oil that has very little oleocanthal or other polyphenols, you might need a cup to see the same results that we saw with about a spoon. So now all of these studies were done on cells, we've done them on mice, but mice are not men. So you can't translate exactly.
Right.
And pharmaceutical companies have shown that for years and years. So it's not the same ratio. What we did actually at Kyoord, I looked at different population studies and tried to extrapolate a dose. So it seems like most studies that show a beneficial effect for consumption of olive oil use anywhere from about 15 grams up to 40 grams a day. And that's equivalent about 1 to 3 tablespoons.
Interesting.
And that was done, most of the studies are done with just regular olive oils that have, let's say, an average polyphenol, average oleocanthal content. So what I can gather is if you use an oil that's higher in polyphenols, you can use less. So maybe you don't need the 3 tablespoons to be effective.
Right.
Maybe 1 tablespoon would be enough.
Right. That's so interesting. And is that raw too, Dr. Limor? Because I also have heard, there's so many different, I feel like.
Oh, my favorite subject.
Yeah, because and I don't know if these are myths or whatnot, but some people say that like cooking with olive oil isn't safe because of its smoke point and that like it could become toxic when it's heated. So like, can you just, I don't know, give us your take on all of that? And I've also heard that high-phenolic olive oil may actually even be more resilient to heat. I don't know if that's true either, but what is the best way to take olive oil?
I think it's probably most effective raw. However, it's also effective when it's cooked. So that answers your last question. Most of the studies that I mentioned, or I don't know if most, but many of the studies that I mentioned, many of the studies that show very strong correlation between olive oil consumption and positive health outcomes for heart health, for cancer, for health.
It's a staple of the Mediterranean diet.
Don't even look at how people consume the olive oil.
Yeah.
And especially in the Mediterranean studies.
Right.
In the Mediterranean, in Spain and Portugal and France and Greece and Italy, people use olive oil as the primary cooking oil. Everybody fits with it and use it. So when they're interviewing people and they're like, they're categorizing them into like light olive oil users, medium or heavy, and then they correlate it with health benefits.
Right.
There's no differentiation whether the subject consumes the olive oil raw or cooked.
Yeah.
Now, for all these people that heard that olive oil, if you fry with it, it's toxic, it causes cancer, something like that. So, like myth. Try to figure out where you heard it.
Right.
I've even heard doctors telling me that.
It's crazy.
But it's not true. There's no study that shows that.
Yeah, that's wild.
And exactly the opposite. So there are studies that have proved that cooking with olive oil, even in high temperature, is healthier than cooking with many other different oils. Now, what's healthier? So we're looking at the compositions of the fat. So when fat is heated, it can get oxidized, and it can create those toxic compounds that are aldehyde-based. And that's a natural breakdown of fatty acids. So the way it happens is because those fatty acids oxidize. Now, what would prevent them from oxidizing? The presence of antioxidants. And olive oil is basically a cocktail of fatty acids and antioxidants.
Right.
So that's one reason. Another reason, and again, I think olive oil is healthier because of the antioxidants, because of the polyphenols. Yes, it also contains the type of fats that are good for us. Oleic acid is an omega-9. Omega-9, there's no recommendations for humans right now. There's recommendations for omega-3 and omega-6, but all indications show that omega-9 is really good for us. Oleic acid, that's a predominant fatty acids, and olive oil is one of the good ones. But the real powerhouse are the polyphenols. Oleocanthal, oleasin, all the other hydroxytyrosol and tyrosol derivatives that, by the way, get produced during the process of the olive oil milling, of making the olive oil. In the olive itself, you have very different polyphenols. But once you make olive oil, you get to those mature polyphenols like oleocanthal and oleasin that are the important ones.
That lends to my next question. How do you ensure that the olive oil is made with that high level of oleocanthal? So I guess my question was like, is that specific to a region in the world? Like, have you discovered that, for example, farms in Greece have higher oleocanthal levels in their olive oil than, say, like a farm in Spain or in Italy?
The shorter answer is yes. But it's not because of the region, it's because of the genetics of the olive tree. So
interesting.
Olive tree. So, trees have genes, and they're very much affected by their genes. And some varieties just make more polyphenols than other varieties. And it's because they have more of the necessary precursors, or they have more of the necessary enzymes to catalyze those reactions to get to those polyphenols. So some varieties are just luckier, better, just like us.
That's so interesting. It's funny too, Dr. Limor. My symbol for well and strong is an olive tree, or an olive branch rather. And the reason I chose that is because I read that, olive trees are some of the most resilient trees out there. And do you think that also lends to the power of, what they produce?
Oh, absolutely. I mean, you ask yourself, like, why they have polyphenols.
Right.
It's and the longevity, and most of those trees are centennials. So the number one important thing, whether an olive oil will be high-phenolic or not, is the genetics, the variety.
Yeah.
But then there's a lot of smaller contributing factors, like the soil, how you grow it, how much water it gets.
Yeah.
It could be the age of the tree, the location. But the second, I would say, most important aspect is when you mill it and how you mill it. When you pick the olives and how you crush them and make the olive oil. Because when the olives stay on a tree for too long, they already start losing some of those polyphenols. They start to oxidize as the fruit mature.
Yeah.
And I think most olive oils are made using pretty mature olives because, they're juicier. They have more oil content, so they give you better yield, and it just makes more economic sense.
Yeah.
But in order to maximize the amount of polyphenols, and that's true across varieties, any variety of olive oil, you have to harvest the olives before they ripen, before they mature, and then you can get higher polyphenols.
Wow, that's so interesting. I'm assuming you yourself have visited many of these farms and seen the entire process. Yeah, that's got to be quite the adventure.
Yeah, that's my favorite thing to do.
I can imagine. I had Andrew Salisbury, who's the founder of Purity Coffee, on the show not too long ago. And he also came from a very different background, became interested in coffee because of his wife's story, and now travels to Costa Rica and all these other countries just to visit with, the coffee farmers. And he says it's the most fun aspect of his job. And I was like, I can imagine.
Oh, yeah. I mean, I love driving the tractor.
You'll have to bring me on your next trip. I'll come.
Oh, yeah, I know. People always ask me to come to Greece with me and lead tours, and yeah, we'll see.
That's incredible. And also too, Dr. Limor, obviously, we want listeners to go pick up a bottle of Kyoord. It's become my favorite olive oil. It's pretty much the only one I use now. But for someone who is in a general grocery store, do you have any tips for them as to what they should be looking for when buying olive oil?
Yeah. So first of all, I have to tell you, if you're in a grocery store today, you're way luckier than if you're in a grocery store 5 years ago or 10 years ago, because there's more market awareness and there's more producers that now understand it. So I think all the advocacy that I do and other producers of higher quality olive oil do trickles down, and it translates, and even grocery stores now have better olive oils in the US than they used to. Mm-hmm. So that's the good news. What you can look for is the best is if the polyphenol level on the packaging is mentioned. So if people discuss how much polyphenols it has, it's not something that's regulated by the FDA. It's not something that anybody's required to do. It's not something that's checked. It's self-reported. But I would like to believe that if a manufacturer writes polyphenol content, it's been verified by a third-party lab. Mm-hmm. That would be the best. Second best is if it probably says high polyphenols. Now, again, it could be
marketing,
a marketing statement, but I don't know. Call me naive, but if somebody takes the time to write that, they're probably better than the average. But little cues are that the olive oil comes in a proper bottle, which means glass, like dark glass container or metal or plastic. Another cue is single source olives, because most of the olive oil in the world that sells in grocery stores, and I've seen it with my own eyes when I go to different mills.
Right.
There's buyers, there's brokers. They buy, okay, I want to have 50 tons from here, and they're get 5,000 tons from a different place, and then they just mix it all in bottles.
Yeah.
And so you can't really control the quality. You don't know what you do. So if you find a single origin, it came from one particular mill, usually it's a sign of better olive oil. But again, you can't tell if it's just something that was done, and it's really good quality, but maybe some from a variety that's not polyphenols. That's harder to tell.
Yeah.
And that's Chinese early harvest because, again, if somebody invests in early harvest, it's a much more costly process because you get less yield.
Yeah.
You most likely get a higher quality. But again, it's not regulated, so somebody can say early harvest. What do you call early harvest?
Yeah.
Well, all my neighbors harvest in February. I harvested in January.
Yeah.
Okay, that's not really
so nuanced. It's so funny too. Whenever we go to Costco,
I would look.
Yeah. No, I was going to say it's so funny too, because whenever I find myself with my mom at Costco's doing our shopping visit and we're getting olive oil, she too, similar to what you said, she's always like, no, make sure it's single source. She's like, I don't want olive oil from 5 different places. She's like, you don't know what's in it. And I never really paid much attention to that. But then I was like, no, she's actually right. And also
it's the smallest font imaginable where they write, it comes from Morocco, Spain, Portugal, Chile, and Greece.
Yeah. And also too, Dr. Limor, so I know you mentioned obviously it depends on the genetics of the tree with in terms of oleocanthal and polyphenol content, but in general, like, would you say it's better to buy olive oil from like Italy versus Spain, or like, is there a country that might tend to have more, I guess, like, better genetic trees?
I'm very biased in Greek olive oils. Yeah. And again, because I've been there and I've seen the industry, there's some awesome producers, for example, in Spain, but most of the Spain production is so industrial.
Yeah.
You drive through this area in Spain called Jaén, where most of the olive oil comes from. And it's miles and miles of like planted tree. It's industrial. It's kind of like our soy or corn production, but just in olives. So again, like corn is not bad. Corn was not bad, but now like everybody, corn, finding like really or farm raised corn that's not.
Yeah.
So the same thing with like a little bit like olive oil from Spain. There's good ones. Just most of it is very industrial agriculture.
Yeah.
So the Greek varieties are known to have higher oleocanthal and oleacein. Not all of them, but most of them. But there's some other, like from southern Italy, especially one from Puglia or Lecce. Definitely some from Spain. I love France and French food and French produce. Unfortunately, I couldn't find any olive oil from France that's high in polyphenols. It's just a fact.
Interesting.
That doesn't exist. I couldn't find it.
Wow.
So I can just tell you, like, if I traveled somewhere without my olive oil, which now doesn't, because I made those little packets.
Which I love. I take those as shots.
If I had to go to a store, so first, right, the first thing I'll look for the container, like only dark glass or metal. I'll try to see single source. And if I'm lucky enough to see something Greek, I'll probably pick that up.
Yeah. I'm so glad you touched on the container bit because I did want to ask you about this. And you mentioned plastic a few minutes ago, but can you also explain why it's so important to not purchase olive oil in plastic?
Geez, that's not my area of expertise. But I think all I can tell you is that there've been studies that compared long-term storage of olive oil in different containers, and they took samples. They kept them in the dark and the right temperature, but they took samples every 6 months, and it shows that olive oil in plastic degrades faster than any other container.
Wow.
So it's just a proof. It's just a fact.
Has there been any research around like olive oil's ability to like absorb like the plastic? Like I know castor oil, for example, like is one of those oils that if you put it in plastic, like it actually absorbs like the BPA and whatnot.
That falls a little bit outside of my area of expertise. So my answer is a little bit more like a layperson based on other that I've read and heard. But microplastics dissolve better in oil rather than in water. It's a better carrier for them. So if there's any kind of degradation of a plastic and microplastics, they probably would be enriched in oil. So things like probably water is less susceptible to that. That maybe not as bad.
Yep. Interesting.
But,
so much to discuss, Dr. Limor. One other question I had for you. I know we're wrapping up on time, but beyond olive oil, I am so curious. You're a wealth of information. What other overlooked foods or compounds excite you most in the field of nutrition and disease prevention, cancer related or otherwise?
Yeah. I think, unfortunately, like, for us as a society, is like we are overlooking most fruits and vegetables out there. Fruits, vegetables, herbs, anything like that. I mean, they're all, people talk about superfoods. It's such a buzzword. Really, pretty much every fruit or vegetable is a superfood.
Yep. So true. So true.
It contains so many nutrients. We need them all.
Yeah.
Like we need a little bit of this and a little bit of that. And by the way, there's so many that we're not exposed to because they're like grown in exotic places. But I think I'm really a big fan of everything that's acidic. Citruses, pomegranates, passion fruit, everything that's acidic, I'm a big fan of, and things that are bitter. Sure, bitter usually means it has a lot of active compounds. So leafy greens of any kind, eggplants, anything that's bitter, I believe is something that contains stuff that's good for you.
So true. I know. As soon as you said bitter, I think of like dandelion roots, right? My mom's been juicing those. I think of like soursop tea. Again, all these compounds that have shown anti-cancer activity. So interesting.
Herbs, fresh herbs. Like for example, like the molecule of that gives mint. It's very similar to those polyphenols to oleocanthal. It has very similar active ingredients. So when you concentrate them, like oils of rosemary is super potent. I use it when I have like a cold or something like that. So all these herbs, utilize in your cooking, but just like use fresh produce.
Yep.
Vegetables, herbs, greens, leaves. Yeah.
Yep. Simple, foundational, but honestly one of the most powerful things that we can do. Yeah, I love that. Well, Dr. Limor, again, we're nearing on time. This has been such a wonderful conversation. I'm so excited to just, share this with listeners. And like I said, it's been a long time coming since I've wanted to have you on. So I'm so happy we were able to sit down and chat today.
Awesome. That was so nice. The time just like flew by.
I know, right? Well, that's how you can tell it's a great conversation. I do want to ask you for listeners, where can they find you? Where can they learn more about Kyoord and pick up a bottle?
Sure. So right now we're not in stores yet. I don't know when we will be. We're a pretty small operation. In order to make really quality olive oil, there's a limit. You can't make too much. So now we don't have enough to supply all the Whole Foods in the country.
For now.
It's online on our website, Kyoord.com, and we also sell on Amazon because for some people it's way more convenient.
Yeah, I'm sure. And also too, Dr. Limor, are there any, I guess, potential new things on the horizon that you could share with listeners in terms of Kyoord, like any new products that might be coming? Like I know you mentioned those olive oil shot packets, which I love. I travel with those. I take them. I think it was a brilliant concept. But anything else that might be in the works that you want to share?
Well, so people always ask me if they can use it on their skin or if I use it on my skin. So the short answer is yes, you can absolutely use olive oil on your skin. I don't use it on my skin because I don't like the smell of it. I'm like, just olive oil. Some people don't mind that. However, so yeah, I'm working on formulations that of olive oil, of self-care products that would be 90-something% olive oil, but would not smell like olive oil.
Very exciting. I love that. Immediately I thought of tallow, right? What was once just used for cooking now, and I'm sure you've seen tallow in skincare. It's like the latest craze. So olive oil might be next. Awesome. And Dr. Limor, my very last question for you. This is always my favorite one to ask. And that is, what does being well and strong mean to you?
I think living life to the fullest, like for me, it's like waking up early in the morning, go to bed later at night and have like a full day that I know I'm self-fulfilling, contributing something to the world.
Yeah.
Either during my work or some other volunteer work that I do. Being active, enjoying everything the world has to offer. I love food, like cooking, eating, nourishing. I love exercising, being active, connecting to others. All these things together, being alive.
Yeah. Amen. I love that. When's your cookbook coming out?
Oh, we do publish a lot of recipes online, but
you do.
I'm so bad at writing the recipes. So I need some help with that.
I hear you. You're like me. I'm just in the kitchen and I don't measure, I don't record things. I just throw stuff together and I say, boom. And my mom's like, what's the recipe? And I'm like, I just threw it together. Awesome. Well, Dr. Limor, it's again such a pleasure speaking with you. I'm really excited to share this. And yeah, I'll let you know when it goes live.
All right. Awesome.